Tonight, we are going to drift near one of the strangest things in the universe, a black hole. Not to make it frightening, not to rush toward it, only to approach it slowly, from a safe distance, and notice what makes it so quiet, so dark, and so hard for the mind to fully picture. A black hole is not really a hole in space. It is not an empty tunnel. It is not a doorway. It is a place where a huge amount of matter has been pressed into a very small region. The gravity there becomes so strong that once something crosses a certain boundary, not even light can escape. That simple idea is what makes black holes feel so mysterious. Light is the fastest thing we know. It carries images to our eyes. It lets stars shine across space. It lets telescopes see galaxies from far away. But near a black hole, gravity can become so strong that even light cannot climb back out. From far away, a black hole may not look like an object at all. It may show itself through a pattern, a dark center, a soft ring of light, stars bent out of place, time behaving a little differently near the edge, a quiet object that can shape the motion of stars. Imagine deep space first. No nearby planet, no surface beneath us, only a wide field of stars. In the distance, there is a region that looks strangely dark. Around it, light seems bent. The background stars look warped, as if space itself has become a lens. This is one way to picture the neighborhood of a black hole. The black hole itself gives off no light we can see, but the space around it can be full of signs. Gas may glow as it falls close. Stars may orbit something invisible. Light from behind it may bend around it. A black hole is known by what it does to everything nearby. This is a calming way to begin. We do not need to imagine a monster. We can imagine gravity. Gravity is familiar. It holds our feet to Earth. It keeps the moon moving around our planet. It keeps Earth moving around the sun. A black hole is what happens when gravity becomes extreme. On Earth, gravity is gentle enough for life. Near the sun, it is stronger, but still not enough to trap light. Near a black hole, matter has been squeezed so tightly that gravity changes the shape of escape. There comes a point where leaving would require more speed than the universe allows. That point is called the event horizon. It is not a hard surface like rock or metal. You could not stand on it. It is a boundary. Outside it, light can still escape if it is moving the right way. Inside it, all paths lead deeper inward. The event horizon is the line after which messages cannot come back. That is why black holes are black. It is not because they are made of dark material in the ordinary sense. It is because light from inside the event horizon cannot reach the outside universe. No reflection, no shine, no signal from within. Only the boundary and the effects around it. A black hole can be small in size but large in mass. That is part of what makes it hard to imagine. A stellar black hole may have several times the mass of our sun, but its event horizon may be only a few miles or kilometers across. A great amount of gravity held in a small region. A supermassive black hole is different. It can hold millions or billions of times the mass of the sun. These giant black holes sit in the centers of many large galaxies. They are not small leftovers from one star. They are cosmic anchors tied to the long history of galaxies themselves. But even the largest black holes are not magical. They do not reach out across the universe and pull everything in. This is an important idea. A black hole is not a cosmic vacuum cleaner. From far enough away, its gravity behaves like the gravity of any other object with the same mass. If the sun could somehow be replaced by a black hole with the same mass, Earth would not suddenly spiral in. The world would become cold and dark because the sun's light would be gone, but the orbit would stay almost the same. Gravity depends on mass and distance. A black hole is powerful, but not unlimited. This helps make the subject less frightening. Black holes are not chasing stars across space. They are places where gravity has a very strong center. If something passes too close, the story changes. But from far away, the universe keeps moving by the same laws it always has. Now, let us drift closer in thought, still safely outside. Around some black holes, there is a bright disk of gas and dust. This is called an accretion disk. The material in the disk moves very fast. It rubs, heats, and shines. The black hole is dark, but the matter near it can become incredibly bright. This is one of the great surprises of black holes. The object itself is invisible, but the space around it can be luminous. A black center surrounded by a ring of hot light. The light may come from gas that has not yet crossed the event horizon. It is close enough to be heated, but not yet gone. The disk may look strange because gravity bends light. Light from the far side of the disk can curve around the black hole and reach us from odd directions. In images and simulations, the disk can appear to wrap above and below the dark center. Space near the black hole acts like a curved glass. This bending of light is called gravitational lensing. It is not only a black hole effect, but black holes can make it very strong. A massive object can bend the path of light passing nearby. So even darkness can shape what we see. The black hole does not shine, but it changes the light around it. Imagine looking at a field of stars through a clear glass sphere. The stars behind it seem shifted and stretched. Near a black hole, the lens is not glass, it is gravity. Space itself is curved. The stars behind the black hole may appear distorted, multiplied, or pulled into arcs. The event horizon has a shadow. Not a shadow cast by light in the usual way, but a dark central region surrounded by glowing material. In early EG, scientists with the Event Horizon Telescope released the first image of a black hole's shadow in a distant galaxy. Later, they released an image of the black hole at the center of our own galaxy. These images are not ordinary photographs like a picture of the moon. They are made from radio data gathered by telescopes around Earth. The telescopes worked together like one planet-sized instrument. The result was a ring of light around a dark center, a quiet proof of something long predicted. There is something deeply still about that image. A dark center, a soft ring, a shape that is not a planet, not a star, not a moon. It is gravity made visible by the light it traps nearby. The black hole itself remains unseen, but its outline appears through what cannot escape. Scientists also find black holes by watching stars. If a star orbits something invisible and very massive, astronomers can study the motion and work out what must be there. The star becomes a clue. Its path says something heavy is nearby, even if that heavy thing gives no light. This is how the center of the Milky Way became so important. Near the middle of our galaxy, stars move around a compact region with great speed. Their orbits show that a huge mass is hidden there. That hidden object is called Sagittarius A star. It is the supermassive black hole at the center of the Milky Way. Sagittarius A star is about 4 million times the mass of the Sun. That number sounds enormous, and it is. Yet, compared with some other supermassive black holes, ours is fairly quiet. It is not feeding wildly. It is not shining as a bright quasar. It sits at the center of the galaxy, mostly calm. The idea that our galaxy has a black hole at its center can sound dramatic, but it is also ordinary in a cosmic sense. Many large galaxies appear to have giant black holes in their cores. The black hole is part of the galaxy's long structure, like a deep weight at the center of a Turnian system. We are very far from Sagittarius A star, about 26,000 light-years away. That means the light and radio signals from that region take about 26,000 years to reach us. When we study the center of the Milky Way, we are looking into both space and time. The center of the galaxy is hidden from our eyes by dust and gas. Visible light cannot easily pass through all of it, but other kinds of light, such as radio waves, infrared light, and X-rays, can help scientists study what is happening there. The universe is not only seen by the eyes, it is read in many kinds of light. Around black holes, matter can become very hot. Gas falling inward may heat to extreme temperatures and give off X-rays. Telescopes that see X-rays can find these bright signs. Again, the black hole itself is dark, but its surroundings can speak loudly in forms of light our eyes cannot see. Some black holes are born when massive stars die. A star spends much of its life balancing two forces. Gravity pulls inward. The energy from nuclear fusion pushes outward. As long as the star has fuel in its core, it can hold this balance. But for very massive stars, the end can be violent. When the fuel runs low, the core can collapse under its own weight. The outer layers may explode in a supernova. What remains at the center can become extremely dense. If the remaining core is massive enough, no known force can stop the collapse. A stellar black hole is born. This means a black hole can be the quiet final state of a once bright star. A star that once shone, burned, pushed light into space, and warmed the dust around it, may end as a dark object. Not gone, not empty, changed into a region where gravity has folded the future inward. The materials from the supernova can spread into space. They may become part of future stars and planets. The black hole remains behind, often invisible, unless it has something nearby to reveal it. In this way, even a black hole is part of the larger cycle of stars. Some black holes are found with companion stars. If a black hole and a normal star orbit each other, the black hole may pull gas from the star. The gas forms a hot disk, glows in X-rays, and gives scientists a signal. The star and the black hole dance together, one shining, one dark. A black hole can also merge with another black hole. When two black holes spiral together and become one, they send ripples through space-time called gravitational waves. These waves are not light. They are tiny stretches and squeezes in the fabric of space, carrying news of a deep collision. Gravitational waves let scientists hear the universe in a new way, not with ears, but with careful instruments that measure very small changes. Some events are too dark to see with light, but they can still shake space itself. Black holes can be silent to the eye and loud to gravity. This is one reason black holes are so important. They teach us that the universe is not only made of things we can see, it is also made of motion, gravity, time, and hidden mass. A black hole is not bright like a star, but it can reveal the deep rules of reality. Now, let us return to the area near a black hole's edge. The event horizon is a boundary of no return, but outside it, matter can still orbit. There may be a disk, there may be hot gas, there may be magnetic fields, there may be jets of particles moving away at nearly the speed of light. These jets are surprising. We often imagine everything near a black hole falling inward, but some material can be redirected and blasted outward in narrow beams. The exact details are still studied, but magnetic fields and spinning disks appear to play a role. A black hole can feed and also send energy far into space. In some galaxies, a supermassive black hole becomes active. Gas falls toward it. The disk shines. Jets stretch far beyond the galaxy's center. The region can become brighter than the stars around it. This is called an active galactic nucleus. When it is extremely bright and distant, we may call it a quasar. A quasar can shine across billions of light years. The light does not come from inside the black hole. It comes from the heated material around it, before that material crosses the event horizon. In this way, one of the darkest objects in the universe can power one of the brightest sights. This contrast is part of the beauty of black holes. Darkness surrounded by light. Silence surrounded by motion. A boundary that cannot send us messages, surrounded by gas that glows intensely. A black hole is not simple emptiness. It is a place where opposites gather. Time also behaves strangely near a black hole. According to relativity, strong gravity affects time. Far from the black hole, time moves in the ordinary way for us. Close to the black hole, an outside observer would see a falling object appear to slow as it neared the event horizon. This does not mean time is broken. It means time is part of the universe, and gravity can shape it. Near very strong gravity, clocks do not agree in the same way they do far from it. This idea is strange, but it is not fantasy. It is part of how physics understands space and time. For sleep listening, we can hold this gently. A black hole is not only a dark object. It is a place where distance, light, and time become deeply curved. The closer we imagine drifting, the more the familiar universe begins to soften around the edges. Still, we remain safely away. The best way to visit a black hole in a calm video is by thought. We can watch the disk glow. We can watch stars bend behind it. We can imagine light circling close to the edge. We can notice the dark center without needing to cross into it. Near a black hole, there is a region where light itself can orbit for a time. This is sometimes connected with the photon sphere. It is not a solid ring, but a path where light can move around the black hole under extreme gravity. It is one of the reasons the images and shadows can look so strange. The idea of light circling darkness is almost dreamlike. A photon, a tiny piece of light, racing around a place it cannot quite leave. Space curved so strongly that a straight path becomes a circle. The universe, usually so open, becomes folded near the black hole's edge. If something falls too close, it may be stretched by tides. The side nearer the black hole feels a stronger pull than the side farther away. This difference can stretch matter into a long shape. Scientists sometimes use the strange word spaghettification for this effect. We do not need to dwell on it, but it shows how strong the gravity can become. Tidal forces happen in gentler forms too. The moon raises tides on Earth because gravity pulls a little more strongly on one side of our planet than the other. Near a black hole, the same kind of difference can become extreme. The familiar idea of tides becomes powerful beyond ordinary experience. Not all black holes feel the same near the event horizon. Around a very massive black hole, the tidal forces at the event horizon can be gentler than around a small stellar black hole. This is one of the stranger details. A larger black hole can have a larger, more gradual boundary, even though its total mass is far greater. But once inside any event horizon, the story cannot return to us. Nothing sends a message back. That is why scientists are careful with language. We can describe what theory predicts. We can study the outside. We can measure effects. But the inside remains hidden from the universe we can observe. The center of a black hole is often described as a singularity in general relativity. This is a place where the math suggests density becomes infinite. But scientists do not know whether this is a true physical thing or a sign that our theories are no longer enough. This may be the deepest quiet mystery of black holes. They may be showing us the edge of a map, not a paper map, but a map of ideas, a place where the rules we use so well outside the horizon begin to lose their clear shape. There is something strangely peaceful about reaching the edge of a map. It does not mean the universe has ended. It means our description has reached a border. Beyond that border, there may be a deeper rule, a quieter layer, or a new way of understanding gravity. This is why the black hole becomes not only an object, but a question. We know much about the outside. We can see effects, rings, disks, orbits, waves, and jets. But the deepest center remains hidden. It stays quiet, not because it is empty, but because no message returns. A good sleep video does not need to answer every question. It can let some questions remain open. What is space like inside the horizon? What becomes of information? What does gravity become when it reaches its most extreme form? These questions are large, but tonight we can hold them lightly. Let us drift outward again. From this safer distance, the black hole becomes part of a larger scene. Stars move around it. Gas may glow near it. Light bends around it. Farther out, the galaxy continues. Star clouds, dust lanes, planets, and empty stretches of space all share the same cosmic neighborhood. In our own galaxy, Sagittarius A star is quiet compared with active black holes in distant galaxies. It may flare sometimes, but it is not swallowing huge amounts of material all the time. Our Milky Way is not being torn apart by its central black hole. It is simply built around a dense, dark center. This is useful to remember. The black hole at the center of the Milky Way is not a daily threat. It is far away, deeply embedded in the galaxy's core. We live in a quiet outer region, around an ordinary star, far from the crowded center. The night sky above us is peaceful because distance matters. Many black holes may be wandering through the galaxy unseen. If they are alone and not feeding, they may be almost impossible to notice. They are dark objects moving through dark space. Astronomers may find them through their gravity, through lensing, or through rare moments when they interact with something visible. This hidden population gives the galaxy another layer. Along with stars, planets, dust, gas, and dark matter, there may be black holes left behind by old massive stars. Quiet remnants, dark seeds, ancient endings moving through the spaces between stars. It can be strange to think that a black hole may pass through space without drama. No bright disk, no visible storm, just gravity, moving silently. Unless it comes close to a star or bends light in the right way, it may remain unseen. The universe holds many things quietly. Black holes also grow. They can take in gas. They can merge with other black holes. Supermassive black holes may have grown over long cosmic time, but scientists are still studying exactly how they became so large, especially in the early universe. Their history is tied to the history of galaxies. When we look far into space, we also look back in time. Some distant bright quasars show that massive black holes existed when the universe was still young. This raises deep questions. How did they grow so quickly? Did galaxies help make black holes? Or did black holes help shape galaxies? The answer may be both, in a long shared story. The universe often grows through relationships. Stars form in clouds. Planets form around stars. Galaxies merge. Black holes feed and merge. Gravity gathers. Radiation pushes. Matter falls inward, and sometimes is thrown outward. Nothing exists fully alone, even the darkest objects. So, a black hole is not only a point of darkness. It is part of a cosmic web of causes. It can shape stars near it. It can power jets. It can mark the center of a galaxy. It can teach us about gravity. It can turn invisible mass into visible effects. Now the journey begins to soften. We are no longer moving closer. We are slowly drifting around the idea, letting it become less sharp. A black hole is a region of strong gravity. The event horizon is a boundary. The glowing disk is nearby matter. The dark center remains hidden. The galaxy turns around it. These ideas can become images. A black circle wrapped in a ring of light, stars bending behind it, a quiet disk turning, a beam of particles reaching outward, a star orbiting an invisible center, a ripple passing through space after two black holes become one. Each image can appear and fade. There is no need to hold them all at once. The mind can let one pass, then another. Dark center, soft ring, curved starlight, quiet gravity, far galaxy, slow orbit. The universe is large enough to carry the thought without asking us to finish it. If the idea feels too strange, we can return to the simplest part, gravity. The same kind of force that holds us gently to Earth becomes extreme in a black hole. A familiar rule carried to an unfamiliar place. The universe does not need different magic. It uses the same deep laws in different ways. Somewhere in the Milky Way, far from us, Sagittarius A star sits at the center. Around it, stars move. Dust glows in other kinds of light. Gas shifts. Telescopes watch. The black hole itself remains dark, but the galaxy keeps revealing its presence, patiently, one orbit and one signal at a time. Somewhere far beyond our galaxy, other black holes shine through the material around them. Some are quiet. Some are active. Some are merging. Some are waiting in darkness. The universe contains many kinds of silence, and black holes are among the deepest. This silence does not have to feel empty. It can feel spacious, a place where the mind can rest on a simple image. A dark center surrounded by light. Nothing rushing, nothing demanding, just gravity, distance, and the slow turning of space. Let the image become softer now. The bright disk dims. The stars behind it blur slightly. The dark center remains, but it does not pull at us. We are far away, safe in thought, watching from a quiet distance. The black hole becomes part of the night, not a threat within it. The mind may enjoy objects like this because they are large enough to hold our attention without needing our personal worries. They are vast, old, and far away. They put the day into a wider frame. A message, a task, a small regret, a plan for tomorrow. All of it can feel less heavy beside the slow gravity of the universe. That does not make daily life unimportant. It only gives it space. The universe is wide. The night is long. The body is here. The mind can loosen its grip. It can think about a black hole for a while, then let even that thought drift away. Imagine the ring of light growing smaller as we move away. The black hole remains behind us, silent. The warped stars straighten. The darkness becomes ordinary space again. We pass through a field of stars, each one steady and distant. The journey outward is gentle. There is no need to look back sharply. The black hole can stay where it is, far away, doing what gravity does. The galaxy can turn. The stars can orbit. Telescopes can keep watching. The questions can remain open. For tonight, the mind has traveled close enough. We drift past dust clouds, past dim stars, past quiet stretches between systems. The bright ring is now only a memory. The dark center is only an idea. The universe becomes softer, wider, and less detailed. Space opens around the thought, and the thought begins to fade. If sleep is near, you do not have to follow the science any further. You can let the words become background. Event horizon, accretion disk, curved light, star orbit, galaxy center. Each phrase can pass like a small light across dark water, then disappear. The body remains in the room. The bed holds its weight. The air is quiet. The voice continues slowly. Somewhere far away, black holes exist without needing to be imagined. They do not ask anything from us. They are part of the universe, whether we think of them or not. This can be restful. The universe continues. Stars burn. Galaxies turn. Black holes wait in darkness. Light travels for thousands, millions, and billions of years. Our own thoughts can rest for a while inside that larger motion. Maybe the mind returns to one final image. A dark circle surrounded by a soft ring. The ring is not harsh. It is warm, distant, and quiet. The center is perfectly black. Around it, space is curved. Behind it, stars shine from far away. Then even that image begins to soften. The ring becomes a glow. The glow becomes a point. The point becomes one star among many. The star field becomes a calm sky. The sky becomes the room. The room becomes the feeling of resting here, now. There is nothing more to solve about black holes tonight. The event horizon can remain a boundary. The center can remain unknown. The galaxy can keep its secrets. The mind does not need to cross every distance. It can stop at the edge and rest. Far away, Sagittarius A star sits in the heart of the Milky Way. Farther away, other galaxies hold their own dark centers. Some are bright with falling gas. Some are quiet. Some are ancient. Some are still growing. They all belong to the same wide universe. And here, in this smaller place, the night is enough. A calm room, a steady breath, a soft voice, a mind that has looked toward deep gravity and can now let the image go. The black hole remains far away. The body remains safe. The thought becomes light. Let the stars become fewer now. Let the dark become softer. Let the ring of light fade behind the eye of the mind. There is no hurry, no countdown, no edge to cross, only space, quiet, and the slow return from a strange idea. Tonight, we drifted near black holes, but only in thought. We learned that they are not empty holes, but regions of strong gravity. We learned that light cannot escape beyond the event horizon. We learned that darkness can be known by what it does to light, stars, and time. And now the journey can end gently. The universe is still there, deep and patient. The dark centers of galaxies remain in their places. The stars continue around them. The room is quiet. The night is open. And for now, there is nothing else you need to hold.